All right. Good evening, everybody. I am Chris from Great Brick Lab, and with me is Amanda. And we are here to give a week 2 update to the Big Robot project, which we're working on. Big Robot is a artificial intelligence controlled Lego sorting machine. And we are working on this project. So we are going to be live for about 30 minutes here. We're going to give an update on what we did this past week, or what Amanda accomplished this past week. And then she's going to show a couple of things. But then quickly, we're going to transition to an AI conversation. So if you're in the live and you want to participate, we appreciate any chats. If you're viewing this as a recording, please put some information in the chat. We don't have the AI 100% figured out, so we really don't know what we're going to do there yet. So let's jump into it. Are you ready, Amanda, to talk about what you did this past week?
Sure. So this week was really the gather materials phase. We took some of the feedback from the discussion at our last live stream about different concepts of the belt and things rolling off of it.
Mm-hmm.
And I came up with sort of a design for some cleats for the belt. And also this week we went to the store and bought materials to start making robot components. And also we ordered the electrical parts as well as additional pneumatics to run the robot sorter. For the most part this week, I've been using our CNC router to cut out the components of the robot. Most of these are made with 1/2-inch MDF board, which was one of the cheapest and lightest wood materials we could find to build with. So in order to machine these parts, I took CAD from Onshape and imported it to Fusion 360, which you guys can see on the screen. Fusion has a nice tool for making G-codes for our CNC router so that we can easily cut out different shapes that we design with very high precision and accuracy. So all we have to do is manually line up to the 0 point that we want and tell the machine where we want our different holes and where we want to cut out each shape, and it will go and do that all by itself without us having to make any sort of complicated rigs. So today's machining was some aluminum parts, which are the brackets that I have here. I made about 6 identical ones and 2 unique ones. This one is to mount the vibrate motor, and the rest of these are for the end conveyor belt deck. And one of them is actually for the spinning carousel. So all week I've been machining for 3 or 4 hours a day. It's been kind of exhausting. The CNC is a little bit slow, especially when cutting aluminum. You can't run it very fast or the tool in the end will break. So yes, it's a little bit exhausting, but it's really satisfying to be able to get exactly the part that you designed.
Yep. Okay, good. So got a lot done this past week, but a little bit exhausting. So thank you for all that work. That's just great. So let's jump into the point of today's conversation. Talk about artificial intelligence and what we're going to do to control the robot. So we have a couple of different choices here, and this is an open conversation here. So we have 2 things that we've been looking at. We've been looking at TensorFlow and Teachable Machine. And we had a little pre-conversation here. So tell me what you like about TensorFlow and maybe what you like about a Teachable Machine.
Okay, so what I initially thought was good about TensorFlow is that it's just a library of tools that anybody can use to write their AI program. So it's very open to different options that you might want. Whereas Teachable Machine is is very user friendly and doesn't have a lot of different options as far as I could tell.
Mm-hmm.
So like if you had some problem with your Teachable Machine model, it would be hard to improve on because it's just got the one button or whatever you have to press to train it. And also, I'm not entirely sure if you can improve your model once you've created it, or if you have to like start from scratch if you want to add more categories. So that's just some more things that I need to look into.
Mm-hmm.
But I know that TensorFlow seems a lot more versatile because it would be written by the makers of the robot.
Right. And so whatever we design in this AI, I don't fully expect that we're going to get it nailed 100% accuracy. The goal is to have something in the next, what we have 9 weeks for production left. So at the end of 9 weeks, something's going to happen. So if you are willing or want to participate, I'm going to throw up on the screen here our banner so that you can participate in this. So givesendgo.com/Lego AI is a way that you could contribute to the creation of the design and the artificial intelligence of Big Robot. The design and the intelligence behind it. So all of the machine design that Amanda's done is all going to be available as open source. So we'll give that away on this channel at the end of the project, wherever we end up at. And then the way you can participate directly with us is to go to tinyurl.com/bigrobotai, and then you can join our Discord and then participate. And we do need help with the artificial intelligence. We have a lot of unknowns. We have some people on the team. We need somebody to help lead the charge. While Amanda is starting to do this coming week, she's going to begin doing some of the assembly. But I think that we have a good 2 weeks before we really need to begin the code development and in the AI. And whatever we develop in the AI, if it's not right and we don't like it, the machine is still there. And hopefully the design of the machine is satisfactory to the point where we can recode it. But like Amanda said, you don't want to have to start all over. You really want something that's going to run and get working. One of the challenges I think we're going to have with the AI, Amanda, and we talked about this in the last stream a little bit, is where do we get our images? So is that still currently a very big challenge for us, is how do we build the images into the program?
Yeah, so we still don't have a real good way of obtaining all the images that we need.
Right.
With Teachable Machine, that is the only thing that you need to do. So you can't do that. You can't make the AI work, or you can't write anything without images. It's all give me data. Another thing is that with the belt, with the cleats on it, there's going to be some different background effects. So a rendered image could be a little bit less valuable. I was kind of hoping that maybe I could get away with like running a first test without any texture on the belt, just so that it would be more friendly to our like prototype AI.
Mm-hmm.
But if we do decide to use Teachable Machine instead of TensorFlow, then you can insert backgrounds images into it. So maybe that would help. I don't know how you would do it with TensorFlow, but I'm sure it's possible. But you would have to have a robot built in order to do that.
Right. Yeah. So Teachable Machine requires that we have something built and we can teach it, right?
Yeah, unless we can make a really good simulation of what the conveyor in the Lego looks like, and capture a bunch of JPEGs of that
Ahead of time is what you're saying.
Yeah.
Yeah. Why wouldn't we just build the machine. If we went the teachable machine direction, we could, well, I see what you're saying. So if we wait to have the machine built, and that's in week, let's say that's in week 10, and we only have a couple of weeks left to teach the machine, we may not have a fully operational machine with only 2 weeks of training. If we had something where we could, you said prototype it or just kind of mock build, then we could start to teach the machine what those images look like, because they have to look similar to what they come across the camera that we're going to use in the system, right?
Yeah, so somebody actually did a teachable machine example where they had bananas and it would tell them how ripe they are. And they just had to add more image data to get it to understand different backgrounds.
Mm-hmm.
So it was fine. They started with just white, and then they have red and green and all sorts of stuff. And even with just white, it was getting pretty accurate on a red background. It was just like not completely perfect.
But a human would have to confirm or tell the machine that, yes, that part meets this category and drop it into this gutter, right?
Actually, so with teachable machine, you do some tests,
right?
And you don't have to do anything. You just have to be like, oh, well, this seems to work well, so I must have enough data. Or, oh, this doesn't seem to be working. I need to get more data.
Okay.
It doesn't let you tweak the parameters as far as I can tell, but I haven't actually
So there's
tried
some
it.
unknowns there. My vision on this was that we would have an application on our phone. An image could come across through the cloud into our phone, and then that image from the camera would go to our phones, and then we could tell it what category that image is going to go to, and that's how we could train the AI. And that could be a crowd controlled AI training. That's a bigger vision of mine, that maybe is a little bit unrealistic. But as far as teaching the machine in different categories, and if we wanted to go completely different categories, we could do that. So, but that's one vision I had for the machine. I don't even know if that's possible or not.
Well, I think, yeah, I mean that's what the universal Lego sorter guy did.
Mm-hmm.
But I'm not sure if that's entirely necessary. Kind of like I was saying with teachable machine, your data just has to be labeled, so you do have to like put the correct part in the right folder. So I don't know if that's what you were thinking you were crowdsourcing.
Right. That data getting into the right folder or a category per part, putting a element into it. I'm just concerned that the number of elements are going to be so varied that if the machine runs into an element it's never seen before, what does it do with it?
Yeah, I don't know.
Yeah, there's a little bit of an unknown there.
It might surprise us though, because actually, if you train it on like a diverse set of parts and say this diverse set of parts is ladders, it will probably begin to see like spikes and drops where there's like a rung and a space and a rung and a space, and then another part that has a rung and a space. It will put it in with ladders. So maybe it will surprise us and we'll be able to figure out stuff it hasn't seen before. But I think the worst thing that can happen is it'll think 50% of this and 50% of that, and it won't have a clue what to do with that.
Okay.
So I think it's just going to be a matter of like when we start, it's going to be kind of crummy, and then we'll just have to add more data to it as we go. And that's kind of where I think TensorFlow might be better, because I'm not seeing that teachable machine will allow you to just improve it on the fly or give it more data on the fly.
Okay, so yeah, we're still very much on the fence whether or not we use TensorFlow teachable machine. Nothing else is in the conversations right now that I'm aware of other packages that we can use, both running on Python. So yeah, I really, that's why I'm calling out to the community here. If you're watching this as a recording and you want to help contribute to the programming of this machine, we need help in this area here. Amanda is definitely capable, and was just telling me in our post or our pre-meeting before this live started that at breakfast this morning she was reading about Teachable machines. So this is how Amanda spends her free time before she goes to machine parts. She's reading about Teachable machine, and she came out with it's not just on JavaScript, but it can also run on Python as a package, which was an interesting way to spend your breakfast time. But that's what Amanda does. So, okay. Great. So we've got about, actually, we're doing pretty good on time here. We may end a little bit early. Anything else on the AI that you want to comment? And if we can get somebody to help, what kind of skills do you think that we need? What would be a really good skill of somebody if they came along to help us?
Well, mostly just some time to go research it, honestly. Me, I'm having some time to research it, and what I'm finding is that there's a lot of stuff out there that's like, use this or use Teachable machine, just try it out. It's easy to use, make your own model.
Mm-hmm.
And get some information on how that goes. Because I'm taking a class and writing, and I'm machining parts, and my whole routine is very jam-packed, so I'm not having time to do that stuff. So
okay, so
it's
basically
almost more just time than skill at this point.
Okay, somebody who's willing to put in the time and contribute to the project, maybe even start the process on the using Teachable machine and actually training some of the core categories. If you come into our Discord, in the what section is it that we have the categories? Because we did do some work on identifying categories in the Discord.
I think it's in AI.
Is it in AI? So if you come into the Discord and you join, come into the development AI and coding section, and you'll find information there about the categories that have been selected. Okay, good.
Brickshop GB has a Google Doc, which includes all of them.
Yep. Thank you, Brickshop GB, for that contribution. And those are the categories I think we're going to go with. I can think of nothing better than the categories that he came up with, and we have to start somewhere. What I've learned in the business model that I've developed at my Lego store is what you give to a human does have limits, and every individual that gets the sorting sheet that we provide inevitably will put some of their own creativity in it, because we've made zero attempt to try and put a picture of every single element on these descriptive or pictorial sheets that we give to people to tell them how to sort into the 22 or so categories that they make. And some people will create an additional category because they're, as they're puzzling through how to sort these Legos, they'll go ahead and create another category because the amount of parts they may have in front of them, or for whatever other reason, they might create a new category. But inevitably, from individual to individual, working off the same sheet, you still get a lot of variety. This machine being trained on an AI basis, the consistency of a part being selected for a particular category is higher level than we can usually get from multiple individuals. So one machine sorting all the parts, even if it's not exactly as the sheet is, but the machine decides those ladders go here, and a 1x3 brick goes here, and the round parts go here. However, that machine decides all these different elements and going to different places. If it's consistently dropping it into that same bucket every single time between those 16 buckets, that breakdown, just that level of breakdown, handing that to another person is an accomplishment because of the consistency that a machine would create. Because there's never the goal of this machine is not to completely 100% eliminate the human person who's going to be doing the cataloging, the quality check, the different mold variations, the color of the parts, the count of the parts. We're not developing a machine to do all those things, at least not yet. I have been told that's not where we should go yet. We're sorting first phase sort, then a second phase sort by a person who then catalogs. We're only replacing first phase sort into 16 different categories. And this is just the beginning. Who knows what another year of this might come after we run this machine. I am ready to transition into what we're going to do next week. What do you think?
I see some questions actually coming into the chat.
Oh, I'm on the wrong page here.
Andrew is asking, hi, do you know what is needed for images to get started? Does it need high or low res? Do the images need to be cropped? Only to show the part. Lighting requirements. Okay. So, I was thinking this through. I would be satisfied with maybe 5 or 6 different angles and just a plain white background. And I don't know if the AI is going to care about resolution, maybe, but just like a smartphone picture is fine. And I actually have a Python script that pretty consistently crops images out of a video. I might be able to use that to crop your parts, but it would be helpful if they were already cropped. But for now, probably just a smartphone picture of 6 different angles on a plain white background.
Of each individual element?
Yeah.
Wow. There's a lot of elements.
Yeah, that's why we were wanting to do it with Blender.
That's asking for a lot, Amanda. That's a lot of images.
Yeah, so that's why. So for that question, I know you're thinking like, oh, we can crowdsource these images. Also know that we're not going to take a picture of every single part known to man. But colors too. We're not sorting by color.
No color assortment, just by shape of element.
So something that was actually quite interesting is there's a website called Rebrickable, and they're working on an AI so that makers of custom Lego sets can just take a picture of a pile of bricks and create a bill of materials out of it. So they have an AI that like finds all of the parts and says what part number they are. And the way that they're crowdsourcing data is they have people build a Lego Technic turntable with like a white sheet of paper, round disc on it, and put a part on it, take like a 10-second video of the part spinning around on the turntable, and submit it to their website. And that's how they're getting data. But it's kind of going pretty slow for them. Like, I think it's been 2 years and they can, or 2 or 3 years, and they can now get 200 different parts. So, like, it's pretty good. But they're not sharing that data. So we would have to go back and spend those 2 years getting those 10-second videos if we wanted the level of stuff that they've got.
Sort 200 different elements, it sounds kind of intense.
Yeah.
This is going to be a challenge for sure. Wow. I was thinking about this in much more simplistic terms. Like you take just grab an element, take a photo of it, and it is what it is. But if a element lands a different way, does the Teachable machine or the TensorFlow can it see the different angles of it if it's rotated a different way?
Well, unless you have a second camera, it's only going to see what the camera can see.
Right.
So I mean, we could add a second camera. That would potentially help.
So there's a question here about the data set that we create. Is that data set the data set I'm welcome to give that for free. However, we need to house it somewhere. We need to keep that data somewhere of all of those images and the categories of those pictures. I just don't think there's going to be enough. How much do you even have anywhere near a guess on the amount of storage we would need to store these pictures? I don't
No,
either.
I don't know those things.
Yeah, I don't even know where to
I
begin to
think I
guess.
don't. What did I download? Like a gigabyte of somebody's 3D rendered ones.
Yeah,
But it was like so few parts, and it was so many repeat images. It was kind of silly.
I think this is going to take a
But
while to
like
train this
the
machine.
just googling it and looking for other people's databases was not working because nobody wants to share.
One thing I know is that if you have Brickstore installed, how much time do we have left here? We have 5 minutes here. Let me see if how quickly I can get this on up and going here. Okay, so immediately put my screen up there, didn't it? All right, so this is Brickstore, and if we come in here and we add, let me just do brick. The black brick. All right, so let's say we have that brick right there. If we right click here, you can actually say save image. And we can save that image as a PNG, and we can give it the part number if we want. But I mean, even doing it that way would be quite intense. So this is a 792C, right? I mean, but overall, I would call that a 2x2 brick. But there's one way to get images of Legos. It's just out of here. We could start with something from that. I don't know if that makes any sense to you, but that's the kind of data we could get, images that are already available out there, but there's only one angle, and the angle is usually not very good.
Yeah, I mean the side of the boat hole. You're probably never gonna see that. Oh, how they did that. But yeah.
Right. So there's these.
Most probably we're gonna have to do some manually taking pictures unless we can get the 3D rendered L draw parts to work.
Well, okay. So there's another thing in here, and let me see if I can find a good example of it. How much time do we have left? I don't think we're gonna get much more into this. Okay, so okay, I have this up here. So let me do this. Let me add this to the stream. So here is this. This is another element, and this is off of Bricklink. But I don't even know if that's even usable.
Yeah, those are pretty fake looking.
But I think it's going to be a low resolution picture. To answer the question about the resolution on the picture, I think it's going to have to be a low res because of the amount of images we're going to have to store in order to accomplish this.
Yeah.
Okay. A couple other people had come in here with questions or maybe comments here. What's the data set? Yeah. So I would love to be able to share the data set. But if we're paying for the storage for it, then we'll have to use the funds that come into the Give, Send, Go. Hopefully they come in and we'll be able to absolutely share that data set. Without the data set, it's almost unusable. So if we can crowdsource building this, if we can find a way to store the images to do this, that is why this needs to be community built. So she's got the design, she's got the robot building it, but now this AI needs to get trained. I just don't think we're going to be able to do it unless we figure out a way to crowd build it. So I'm thinking something on the phone where an image comes across the robot and somebody clicks a button and says it's this category or this folder. That's what my vision was on it. And we do have somebody who might be able to program that for us, who's already in the Discord. I don't know.
Yeah, actually on that note, once I have the basic assembly put together, I can actually just run the motor off of one of our FTC robot controllers.
Mm-hmm.
Well, since our circuit board isn't going to be here for a while, I can just run that conveyor belt and drop pieces on it and send, or like have a camera run at like a very low frame rate and just send like a stream. I don't know if it could be on Discord or Google Drive or something.
I don't know where
And
either.
just have people take the images and sort them.
Yeah, I was thinking that we'd run
It'd
the
be like
robot.
sorting Legos.
Yeah, basically the image database builds. Somebody has to come in and be able to hit look at the image and then drop it to a folder, and then that image is now cataloged. Alex here did some math for us. He's basically saying it's 5,000 gigabytes, so 5 terabytes of data, essentially, is what we would need. That's quite a lot of data. If based on the description that you were talking about in the videos, he did some math for us there real quick.
So that's all 9,000 parts.
9,000 different unique parts. Yeah. So I don't think there's any way we're going to go at 9,000 parts. The machine's just going to have to guess at a lot of them, and that's what this whole thing is about. It's about guessing at it, getting it the same guess every single time, as long as it drops it in the same bucket. You don't have to have it trained for 9,000 parts. You just have to have it trained enough that it decides to put it in a bucket, and it does that again and again and again. Right.
Yeah. So it will be interesting to find out how many that is. But yeah, now we at least know what our maximum is in terms of storage.
All right. So we're right at time. Do we have time to do a 1-minute update on what we're going to do in the coming week?
Well, my clock says 7:31, but I can tell you that next week I will be screwing things together and gluing things together, and hopefully they all work.
If everything goes to plan, next week will be a little bit of a show and tell. We'll actually have some time to show the robot or what Amanda has been able to assemble in the last week here. So probably be about a half hour next week too. We'll get into a little bit longer streams, especially if we get some assistance in the AI. I'd also like to have people come in as guests as well in future upcomings. So we have 9 more weeks. We have 9 more of these streams that we're going to do as we go through. And then at the end of 9 weeks, we're going to release whatever we have. And hopefully we'll have something that we can either train or has been trained, teach, and into the future beyond that. So thanks for being here, Amanda.
Yep, thank you for having me.
Yep, you bet. Absolutely. So we'll see everybody again next week.
Everybody have a good weekend.
Yeah.